Hey, today we are going to talk about number of provinces, which is nothing but like how many components are there in the given graph. Like this is one component and this is another component. So totally for this particular example, we have to written two. How do we find out? That's what the problem is. But the input is going to be something like this, where we have an array and the elements are going to be like this. Okay, 1 comma 1 comma 0 0 comma 0 comma 1. Okay, this is the array. So what it says, this particular node has connection to who and all. That's what this is representing. 1 has connected to 1. Does 1 has connection to 2? Yes. If it is 1, then it has a direct connection. If it is 0, then it doesn't have any direct connection. 1 doesn't have any direct connection to 3. That's why it's 0. So if we take this one, 2 has connection to 0. Yes, that's what. 2 has connection to 1. 2 has connection to 2. Yes. From here we can reach here. Does 2 have connection to 3? No. That's why it's 0. So that's how the data is given to us. It's a little tricky. I mean, what we have to do is like using this data, we'll have to convert this data into an adjacency list. Once we have adjacency list, then rest all is simple. The only tricky part here is like we have to convert this input. Using this input, we'll have to construct an adjacency list, and from there it's just a DFS. What we have to take here and do a DFS, and take from here, do a DFS, and take from here, do a DFS, and count how many times we could be able to run this DFS. Like for example, we have a global visited array. When you do from your DFS, and you would have marked all the visited element, and before you start doing any, before you start picking any node to do DFS, check whether it is already visited or not. If it is not visited, keep incrementing the count. Then finally return the count. That count is going to be the number of component. That's how we can solve this problem. Thanks for watching.